Welcome back. Having learned the input factors and their sensitivities for the BSM model, we shall learn some of their practical usage in the derivatives market. We shall learn how to establish a delta hedge, what is gamma risk, and implied volatility, and how it is used in options trading. Let's jump right in. In our last lesson, we learned that delta is the change in option price for a given small change in stock price. We had this example of a call option with strike at $45 and stock price is currently $50. At this price, the delta is 0.74. This means that if the stock price increases by $1, the call value is estimated to increase by 74 cents. So let's say you own 100 underlying shares and you wish to hedge against the volatility of the stock price. That is, you do not want your portfolio value to fluctuate as the stock price changes. What you can do is to create a delta-neutral portfolio that is a combination of stock component and an opposite position in options that replicates the exact gain or loss in value in response to stock price fluctuation. Since you are long stock, you should be shorting N units of options. Let's learn how to determine this number. If you look at it, for every $1 increase in stock price, the call option price should increase by 74 cents according to the delta estimate. 1 over the delta units of the call option would produce equal magnitude of change in the call component. This is therefore the number of option contracts required to hedge one share. In general, the number of options needed to delta hedge is the number of shares to hedge divided by the option delta. So, for this case, there are 100 shares to hedge, and the call option delta is 0.74. So the number of options for hedging is 135.1. You should short 135.1 call option contracts on the stock. This formula is the same for both call and put options. Delta hedging can also be performed with put options. Let's say there is a put option on the stock with a delta of minus 0.2. The number of options you should short is minus 500. To short a negative number is also to long the positive of that number, so in this case, you should long 500 put options. You should be aware that delta hedging is accurate only for small changes in stock price. Delta changes as the stock price changes, so in order to maintain an accurate hedge, you will need to continuously adjust the option position, a process known as rebalancing. So for example, at $51, the delta of the stock increases to 0.81, the call position should be reduced to 123.5 contracts to maintain an accurate hedge. The frequency of rebalancing is really at the discretion of the investor. If it is too infrequent, the hedge is less accurate. Rebalancing too frequently can incur significant transaction costs. However, even if one can hedge perfectly, there is still the risk that stock prices can jump, leaving positions unhedged. This is known as gamma risk. Again, using our example from the last lesson, adding gamma adjustment, we've estimated that if the stock price jumps from $50 to $60, the call price would change by $9.15 if the stock price jumps $10. So for our delta neutral portfolio, the stock position increases by $1,000, but the short call position decreases in value by $1,236. The net portfolio value decreases by $236, so the delta hedge was not that effective because of the jump in price. Gamma risk is the risk of an ineffective hedge when the stock price jumps. This is because delta is a linear estimate, whereas the actual relationship is a curve, where the curvature is explained by gamma. The higher the gamma of the option, the higher the gamma risk. Now's your turn to practice. Recall this example from our last lesson. We've calculated the delta of the put option is minus 0.4467. What position in the put option should be taken to hedge a short position in 1,000 shares? Pause the video now and work out your answer. And we're back. It's easy to calculate the number of option contracts to enter. You should get minus 2,239. The harder part is to determine the position. Remember, the derivative position must always be opposite that of the stock position to hedge. So if you are short 1,000 shares, you should long minus 2,239 put options. In other words, you should short 2,239 put options. Next, in our last lesson, we estimated that if the stock price increases from $80 to $100, the put option value should decrease by $1.93. Determine the hedging shortfall for the delta hedged portfolio. Pause the video now and work out your answer. And we're back. If the stock price increases from $80 to $100, the short stock position should decrease by $20,000. However, the short put position will increase by just $4,321. For this case, there is a hedging shortfall of $15,679 due to the jump in price from $80 to $100. And to end this lesson, let's have a quick discussion on implied volatility. In our last lesson, we learned the 5 key inputs to the BSM model. Of the 5 inputs, exercise price is fixed on the contract. There is no ambiguity on time to expiration, and stock price and risk-free rate are observable from the market. The only input that is unknown is stock volatility. Stock volatility here should be the volatility going forward, and it is usually estimated using past movement of the stock price. All 5 of these inputs are fed into the BSM model, and we arrive at the value of the call or put option. The BSM model can also be used in the reverse, that is to input the market price of the call or put option and solve for the implied volatility of the stock. As you can see, the volatility term is embedded deep in the D1 and D2 terms, so it's quite difficult to solve it on paper. Rather, computers can quickly solve it using trial and error approach. Implied volatility can be interpreted as the market's view of how to value options. In the option markets, participants sometimes use implied volatility as the medium in which to quote options. For example, if a trader believes that the volatility of a stock is 30%, but the implied volatility of its call or put option is just 25%, he would long the call option. If he is right, the option value would increase if market participants eventually agree that 30% is the appropriate implied volatility. In essence, as the value of both call and put options increase with volatility, a trader should long the option if the implied volatility is lower than expected. Conversely, he should short the option if the implied volatility is higher than expected. And that concludes this topic on the valuation of contingent claims. Take a break, and we'll see you at the next topic.